Hey guys, so we're going to talk about the average function value. This involves calculus, involves an integral. Here's the notes right here. So the way these work is they're going to give you a function, some f of x, it doesn't really matter what it is, and they're going to give you two endpoints of an interval, say 1 to 2. And they just want to know of this function, so for this one I just made the 3x plus 2 be something like this. They want to know between x equals 1 and x equals 2, what's the average value of all these y's, is essentially what's happening. We don't really need calculus for something like 3x plus 2, but as the functions get more complicated, we're going to need calculus. So now we have our function and our endpoints of our interval. So the a, this is the 1, the lower end of our interval. It's also the a right here as well. And then the b is the 2. So it's going from a to b, and this is our function. So you just plug in for b, plug in for a, and then plug in your function, and then take the integral and multiply it by the fraction that you stuck at the beginning. So I'll show you one. I was originally going to do one of the problems, but I'm kind of interested to do the problem I have created. I think it could be interesting to see the linear, because then you can actually see what's being found with these. So we'll go back to our f of x equaling 3x plus 2 and our interval from 1 to 2. So if we graph this, 3x plus 2. So there's a sketch for 3x plus 2, and we have these two endpoints of our interval. This point right here is 1, 5, and this point is 2, 2, 8. So now what is the average value? Well, since this is linear, we know that it would average out by just whatever's in the middle. To find out what's in the middle of 8 and 5, we can add 8 plus 5, and that gives us 13 over 2, which is 6.5. So 6.5 should be the answer. Now let's try to use this formula. So for this formula, we know our a is 1, our b is 2, and our function value is 3x plus 2. So I'll just plug everything in. 1 over 2 minus 1, integral from 1 to 2 of 3x plus 2 dx. Now to take 1 over 2 minus 1, well, that's unfortunate. It just ends up being 1. So this really doesn't do anything. And then the integral of 3x plus 2 is 3x squared over 2 plus 2x from 1 to 2. Now we can plug in 2 and subtract plugging in 1. So it's got a little messy, but I think I have more room up here. So 3 times 4 divided by 2, so we'll just call this 12 over 2, plus 4 minus 3 over 2 minus 2. And that's because the negative distributed. Then simplify this. 6 plus 4 minus 1.5 minus 2, 10 minus 3.5, and the answer is 6.5. That's the same thing we got over here. So that's all the average function value is doing. It's finding what is the average value of that function over the time. Obviously, with something linear where we can just do something this simple, we wouldn't do the integral. But as we get more complicated functions, this integral is nice. Maybe I'll do one more. I'm going to go do the one I was originally going to do. So show average function value. And if you remember, the notes for that, for f of average, is equal to 1 over b minus a from a to b of the function value dx. So our a is the 0, our b is the 3, and this is our function. So we just plug it into the formula. 1 over 3 minus 0 times the integral from 0 to 3 of 5x squared plus 8x minus 10 dx. So we can clean this up. 1 over 3, and then this would be 5x cubed over 3 plus 8x squared over 2 minus 10x from 3 to 0. And then now we can plug in 3. 3 cubed over 3 plus 3 squared over 2 minus 10 times 3. All of this is times a third, and it's also going to be subtracted from when we plug in 0. So it's going to be 5 cubed over 3 plus 0 squared over 2 minus 10 times 0. So next we bring down the 1/3. 3 cubed is 27, and 5 times 27 is 135. So this is 135 over 3 plus, and then 3 squared is 9 times 8 is 72 over 2 minus, and 10 times 3 is 30. And then all of these just change into 0. 135 over 3 is 45. We'll bring down the 1/3 plus 36 minus 30. And that's 1/3 times 51. And that ends up being 17. So the answer should be 17. Let's check it. So this is how to do average function values. Take note of this. It's kind of a nice, elegant problem. If you want to try more of these, I have this page on andymath.com for average function value. There's notes and there's more practice problems, and they all have answers. So you can try them out. There's also related pages for all kinds of integral practice for different topics. I'll include a link down below in the description. Please like this video and subscribe to my channel, and I'll talk to you guys soon. Bye.